Thank you very much for the question. I think this is a very good question, and I want to provide a comprehensive answer here. So basically, my path into green buildings, renewable energy, and environmental monitoring really began during my undergraduate years at North China Electric Power University. Actually, in that university, energy research is a core pillar across the faculty. Uh, During my undergraduate time, I was fortunate to be mentored by Professor Zhenyu Zhao, who guided me there in my third year to study the management process of wind power project in China. Basically, that work really produced a good publication in a top journal named Renewable Energy. And that is a really valuable experience to me. And the experience showed me not only the intellectual excitement of the renewable energy and green building fields, but also the practical significance of that research area to society and industry. From that point on, I became deeply engaged in renewable energy and green buildings and have continued along that trajectory ever since. From this experience, I want to mention also that now I think it is fundamental. Basically, mentors play a very crucial role in shaping young researchers' directions. The mentors research area really opening doors to impactful questions and rigorous method. Uh, and you will notice that my area is renewable energy, green building, environmental monitoring. The focus of all this area is about environmental performance of our building sector, right? So right now, actually, another important reason is the environmental impact of the building sector. We all know that buildings account for a substantial share of global energy use and emission across the life cycle from materials and construction through operation. Integrating renewables, whether through on-site solutions like rooftop solar, geothermal, or through clean grid integration, turns building from passive energy consumers into active participants in the energy transition. Coupling this technology with energy efficiency, demand flexibility, storage, intelligent controls can significantly reduce operational carbon while also improving the resilience and cost stability. And as my research progressed, I gradually realized that perhaps focusing solely on energy efficiency can sometimes overlook other critical dimensions of environmental performance in the built environment. Basically, we should not improve energy metrics at the expense of occupant health, construction impacts, or urban environmental quality. That insight really led me to actually broaden my work into the environmental monitoring of other environmental aspects. For instance, tracking factors such as particulate matter levels on construction sites. By monitoring the comprehensive environmental parameters alongside the energy performance, we can identify trade-off early and design interventions that are genuinely holistic. What really inspired me is actually the system level perspective. So we need to connect energy, material, emission, and even some health aspects to achieve building and cities that are not only environmental friendly, but also comfortable and safe for the people who use them. Yeah, thank you. That's my answer. That's a very good question. And absolutely, yes, one of my project really lead to an unexpected result. So basically, I have a project that is about study the urban level adoption of residential solar PV in Australia. So basically, my research group assembled a large data set covering more than 2,600 postcode areas in Australia. And we integrating installation records with social demographic indicators to understand in Australia who adopt solar panels on their rooftops and for what reasons. So this work actually produced a series of papers. For instance, we have a paper called How Does Residential Solar PV System Diffusion Occur in Australia? A Logistic Growth Curve Modeling Approach. That paper is published in Sustainable Energy Technologies and Assessment, a very good journal. We have also published another paper called Regional Disparity of Residential Solar Panel Diffusion in Australia, the role of social economic factors, that published in the Q1 top journal of renewable energy. So from this work, we find a surprising result. So basically, we find a consistent pattern that in Australia, lower income areas exhibit higher rates of solar panel installation. So which means it is not the rich areas, the rich people who adopt more solar panels. It is the opposite. It is the poor household, poor areas adopt more solar panels. Basically, this runs counter to findings in several other countries, for instance, the United States. And most studies in the United States found higher income households or areas typically will lead the solar panel adoption. So this is a really surprising result, and we want to find the reasons why in Australia it is the household with a lower average income have a higher solar panel installation rate. So I think that the reason could be, for instance, the Australia PV market has benefited from strong competition, economics of scale, and streamlined installation process that's really driven down system price substantially. So the lower capital basically reduce the income barriers relative to other countries, for instance, in the United States. Compared to the solar panels in the United States, the solar panels here in Australia is very cheap. So even the poor suburbs, the people with lower income levels can afford the solar panels. But the most important reason actually is the lower income household tend to be more responsive to the immediate tangible cost saving from solar. So because the solar panel has the ability to cut electricity bills, combined with favorable feed-in tariffs in certain periods and regions, so those benefit is more attractive to people with lower income. So basically, in a simple sentence, rich people, they do not care too much about the cost saving of solar panels. But the household or areas with lower income levels, they really care more about the cost saving, the electricity bill savings, and also the feed-in tariffs are brought by the solar panels. So this makes that why is the household, the areas with lower income levels have a higher PV installation here in Australia. So I think that this finding really influenced how we think about equity and impact, because a lot of researchers previously would assume that the early solar PV adopters must be the wealthier household. But in our study, we show the opposite. From our data-driven analysis, we use data to show that in Australia, it is the opposite, which means residential solar PV historically improved the energy equity and for all, basically improved energy equity because lower income areas adopt solar PV more. So solar PV improve energy equity, but actually it could be the opposite in a lot of the other countries. Yeah, so that's one of the unexpected findings from my previous research. Thank you. Yes, that's also a very good question. I think all researchers would have interdisciplinary perspectives and international collaborations. And in my case, I think one of the most important interdisciplinary collaboration experience is my collaboration with researchers from the Australian Institute of Machine Learning over the past 4 years. So basically, those collaboration with computer science colleagues from Australian Institute of Machine Learning has been especially influential in shaping my research at the intersection of environmental monitoring and smart construction. They have expertise in computer vision, data analytics, and those expertise really enable my research group to push beyond conventional monitoring method and deliver scalable low-cost solution with real-world impact. I'll give you an example, for instance. Recently, we published a paper about automated construction progress monitoring in a very good journal, in Journal of Construction Engineering and Management. So in that work, together with the support from Australian Institute of Machine Learning, we explored an accessible, automated interior construction progress monitoring workflow. That workflow leverages an iOS-based LiDAR scanner for on-site data capture and computer vision for detecting drywall faces. So basically, in our approach, rather than relying on the traditional widely used RGB imagery, we innovated by extracting and using geometric features directly from point cloud models captured by basically iPhone Pro. right? So the reason we do this study is a lot of researchers, a lot of studies do point cloud, do laser scanning. We use expensive laser scanners. And one of the key barriers to the wide adoption of laser scanning in industry is the cost. So a lot of small to medium-sized builders, contractors, they do not have the capital, they do not have the money to purchase those expensive laser scanners. So even though they know it is very cool, it is very useful, that laser scanning can bring to the industry, but the equipment is expensive. So that's perhaps the most significant barriers to the wide adoption of laser scanning. And, I had a discussion with my collaborators from the Institute of Machine Learning. We think, okay, uh, people all realize the benefit, but cost is a significant barrier. How about we do a little study that investigate iPhone Pro? Because iPhone Pro now has an embedded small laser camera, laser scanner. So if we can somehow test the ability of the iPhone Pro in terms of accuracy, point cloud models, automated construction progress, then basically we move the step forward. We can show to the industry that actually cost is no longer the issue. You can use iPhone Pro to do your laser scanning, right? So basically, that's how we come up with the idea. And then I collaborated with Australian Institute of Machine Learning colleagues. So we did this little study testing the ability of iPhone Pro in the potential of it in automated construction monitoring. So in that research, we adopted VoltNet as the core detector, and we successfully demonstrate the usefulness of the iPhone Pro embedded laser scanners cameras, but also we show some limitations of the approach as well. But despite the challenges such as limited training data and lower resolution from the iPhone Pro sensors, our approach achieved accuracy on par with other CV-based detection method. So the paper showed the feasibility of integrating iPhone LiDAR for construction element detection, lower cost and operational barriers compared to the expensive traditional laser scanners and high-end cameras. And our research really contribute a benchmark data set for interior drywall detection that can help validate future algorithms. I think that's one of the case really showing that how interdisciplinary research, in my case, is collaborating with computer science colleagues can really move the smart construction field or environmental construction step forward. Another case would be we also have work in terms of monitoring particulate matters. For instance, people are familiar with PM 2.5, right? So the air quality, air pollution issues. So basically, we monitor PM1, PM 2.5, and PM 10 generated from construction sites. And we publish the work in Journal of Environmental Management. Construction activities generate very complex, highly dynamic PM exposures. Again, we collaborated with machine learning colleagues. We deployed high-resolution, real-time monitoring across different construction zones. We collect more than 28,000 measurements of PM1, PM 2.5, and PM 10. We investigate the relationship between these PM levels with construction activity scenarios and with external microclimatic factors, for instance, temperature and humidity. And we use AI algorithms to also build forecasting models. So basically, we can somehow forecast if the temperature is this, humidity is that, the background PM level is that, and you're doing this sort of construction activity, probably you will generate this level of PM. So basically, we built the forecasting model based on AI algorithms. And this is a result of true collaboration with computer science colleagues. But I also want to say that these collaborations did not just add advanced tools to our toolkit, but actually these interdisciplinary collaborations reshaped our research focus. Before collaborating with computer science colleagues, I think little about affordability, usability, but now really affordability and usability and the ease of use is really the focus, one of the focus that my research currently have. So I think, we will keep the interdisciplinary collaboration, and in the future, the environmental intelligence can be embedded directly into construction workflows and workplace health protections. Thank you very much. That's my answer. A lot of researchers are interested in the area of sustainable construction, and we all focus on different aspects of sustainable construction. And to me, I think there are two areas that I believe, or at least in my opinion, really excite me most. So one is still about renewable energy. So basically, one is the fusion of building integrated renewables and on-site storage with virtual power plants. So when rooftops, building facades, building canopies generate clean power and battery or thermal storage to capture the clean power, the buildings will stop being a passive energy consumer. It will become a flexible revenue generating energy assets. So we can have BIPV on roof and facade. We use very high efficiency PV technologies, and we use solar canopies. So all of the building integrated photovoltaics can produce clean energy right where it's used. So basically, it will cut losses and it will match the peak demand. And we can match the building integrated renewables with batteries or thermal storage, and to smooth the intermittency and shift self-consumption to high value hours. By all these practices, so basically clean energy generation, energy storage, and occupant energy behavior optimizations, right? So we can shift the self-energy consumption to the high value, energy generating hours. By combining all of this, we can make building truly net zero energy. Building no longer become an energy consumer, building become a revenue generating energy assets. So I think that's one of the area that still excites me. Some people may argue that, okay, we have solar panels many decades ago, and it's not something new. But still, solar panel are not still widely adopted in a lot of the buildings. Actually, Australia is the country that perhaps has the highest level of residential solar PV adoption, and still only 1/3 of Australian households have solar panel on their rooftop, which means 2/3 of all Australia homes, Australia households do not have solar panels. And Australia is perhaps one of the best practice, widely adopted solar panels. Still, 2/3 of the household do not have solar panels. So yes, solar panel is not something new. It is a long time ago we have the technology, but the use of it is still not ideal, right? The area still receive a lot of research attention, and it is still very important. So I think that's one of the innovation or trend that excites me most. The other one that excites me most is about circularity of building or construction materials. So we talk about building material recycle a lot, right? So construction waste management, a lot of researchers do construction waste management, material recycling. And if we want to do a deep material recycling, we need to somehow adopt the concept of urban mining. So basically, we treat demolished buildings as material banks. So instead of landfilling, we carefully deconstruct and recover usable parts from demolished buildings. For instance, we recover steel, timber, glazing, MEP equipment, etc. And then we can give each item a simple digital material passport. So that digital material passport will document, okay, what the component is, what the size, what is the condition, what is the remaining lifespan, etc. We list those verified recycled component somehow on a trading platform where designers and contractors can search, compare, and buy for new projects. And we can build in logistics, quality checks. Basically, we build a comprehensive, holistic ecosystem of urban mining. It's just like secondhand cars or secondhand computers, right? So in Australia, a lot of people do not buy new cars. We buy secondhand cars. So we have dealers to verify, to check the quality of the secondhand cars, and people buy secondhand cars from dealers. We have website advertising secondhand cars, right? So now imagine we do the same for demolished building components. So when we demolish a building, we no longer put it in landfill. We carefully recover the useful parts. We put it on a website, and people can buy the part from the website instead of treating them as a waste. We recover the value, right? I think this really also very be excited to me. And the approach not only cost waste, but also embodied carbon, right? We reduce the cost, the lead times. We really turned end-of-life building asset into valuable inputs for future construction. So yes, I think that's the two areas that really excite me most. Thank you. Thank you for the question. I think my suggestion for early career researchers that interested in these areas would be, we need to find very good research questions. And in a lot of the cases, a very good research question would come from interdisciplinary perspectives. For instance, we can look at the nexus between computer science, AI, building science, construction management, human health, and environmental science. So from this interdisciplinary perspective, we can find a lot of interesting research questions. The next one would be, be comprehensive and holistic. We use a system perspective. So we don't treat buildings only as buildings. We treat buildings as parts of a larger social technical system, right? So we have building connected with power grids, with water infrastructure, we have material supply, we have urban microclimates, right? So put building in a broader, big context and try to investigate and optimize the building performance to the whole social technical system. I think that's also my suggestions. And if you happen to be in the field of building science and you want to use simulations, you need to pair the simulation with field validation so that your simulation insights has an actual reality background. It is really proven. The other final comment I have is please consider equity. So we can have a lot of technologies, right? So in each of the papers, we can propose something new, and we argue that we bring the benefit to the society. But I want to recommend early career researchers to think about, okay, your solution benefit whom? So really think from an equal perspective. So who benefit from your research? Who pay the cost for your research? And whether the benefits that your research bring is equal to all the populations, to all the people, or some people will benefit more from your research than others. I think this is very important because we talk about sustainable construction sustainability. No one should be left behind, right? I'll give an example. For instance, there's a concept called green gentrification. Basically, in a lot of the places, we want to improve the environment. So we develop parks, right? We grow a lot of trees. We develop parks. It's very beautiful. It cool the urban environment, mitigate the urban heat island effect, right? So it's very good. But in a lot of the historical cases, we observed that once the park is developed, the property price in that area increase. The rental cost in that area increase, which means some people with lower income in that region, they may live in that region for a long period of time, right? It is affordable. They live there for maybe 10 years, but once the park is developed, the rental price suddenly increase. They cannot afford to pay the rent, so they have to move out from the area. Now you see, the benefit brought by the park is not equal. It benefits the rich people more than the people with lower income. Developing park is a good thing, but some people can be harmed. Some people have to move out of the area simply because the park increased the rental cost in the area. So I want to talk about the cases because, we need to think about who benefit from our research and who pay for the cost. And as early career researchers, you guys have bright futures to influence the way that we move towards true sustainability. And I hope that in your research, you design for a fair and just sustainability transitions to align your engineering choice with some social protections. That's all. Thank you very much.